maximum shear stress planes and the planes of pure shear stress. Already the planes you have studied, but how to calculate the stress on the maximum shear stress planes as well as planes of zero normal stress or planes of pure shear stress. So we'll discuss some more questions that will come to so can you complete this question now? For the biaxial state of stress as shown in the figure, determine principal plane location, principal stresses. All these are separate questions for objective point of view. 3 objective questions I made into 2 single question I made it now. The mass only principal plane or principal stress or major principal stress and plane location. So when you want to do all this calculation, what is required? Now sigma x, sigma y, tau xy. Now can you write down what the sigma x, sigma y, tau xy? Now this is what now? Default you are going to take the x phase. So this will become the x phase. But here this stress is inclined to this x phase. This stress is inclined to this phase. So if you resolve it, you are getting this component is (200 cos 60). That is 100 megapascals. So this will be equal to sigma x. And you are going to get a one vertical component. Vertical component is 200 sin 60. (100√3). Now what the sigma x? Now 100. Some students are going to sigma x 100. Sigma y means they are going to take this 100 plus 100√3. This 100√3 is not the sigma x or sigma y. It's the tau xy. Tau xy. But if it is going to be what? Sorry, the y direction, it is also what? It is not what? This is a parallel to x phase. It is a tau xy. But some students are mostly they are writing what now? Sir, sigma x equal to 100. Sigma y equal to, they will write down 100 plus 100√3. 100 plus 100√3. That's the incorrect. Now sigma y means perpendicular to y phase. This is a y phase. This is only a sigma y. This will be a tau xy. But in the question, complementary shear is not there. So always, even if the complementary shear is not there, you have to consider now. Once you know this, remaining is simple. So now directly, remaining calculation you can do it now. Sigma x 100. Sigma y. This is directly sigma y. Sigma y is also 100. Then tau xy minus 100√3. Minus 100√3. That's all. Remaining calculation you can do it now. But the first one is asked now. But most of students, they will write down like this. Now sigma y means they will write down 100 plus 100√3. This is incorrect now. It is incorrect. If you remember this, just now you studied a tan 2 theta equal to 2 tau xy upon if you know the tan 2 theta equation, directly can write down. Otherwise, you can use the what now? What the actual method to get this now? Equate the tau s equation to 0. Or what the other method you have studied now? This is the method. But if you already know that equation, directly tan 2 theta equal to minus 100 root 3. So something by 0 is the infinity. When the tan will be infinity, 90 and 270. But if you ask major principal plane, determine the major principal plane, everybody is going to write down the 45 degrees. It is not the major plane, we don't know. It simply is giving what now? On these two planes at an angle of 45 and 135, at an angle of 45 and 135, shear stress becoming 0. On one plane, normal stress maximum, another plane minimum. We don't know which one is the major principal plane. This method will give only plane, but which one is the major principal plane, which one is the minor principal plane, we cannot tell it now. Next, if you ask only principal stresses, then directly you can use your equation 1 by 2 sigma x plus sigma y plus or minus second term will become 0. Four tau xy square minus 100 root 3. Next, principal stress and corresponding plane location. This method will give only principal stress. This will give the only principal planes. Now we ask sigma 1 and theta 1, sigma 2 and theta 2. Then in that case, what do you have to do it now? Then what do you have to do it now? Already got the principal plane location, you got it. So in sigma equation, substitute 45 degrees. 1 by 2 sigma x plus sigma y. Second term will become 0. Sigma x minus sigma y, second term will become 0. Because of sigma x and sigma y are equal. Plus tau xy. Now to get the another principal stress. Now finally what the sigma 1 larger of which is the larger value now. Now what the theta 1, what the plane location. Theta 1 means what? This plane location. How we are getting this 273, 135, 45 degrees now, 135. So this 273 you are getting by substituting what? 135. So theta 1 is about now 273.205, sorry, 135 degrees, sorry, 135 degrees. And what the sigma 2? Smaller. which is a smaller value now, minus 73.205. And what this plane location? Means the tensile stress is become maximum. Tensile stress becoming maximum at what angle? 135 degrees. And compressive stress is maximum at an angle of 45 degrees. But most of the students, if you ask this question, only if this question is asked now, if you ask only this question, what the most of the students, they will do it now. They will use this method now. They will use this method. Then what they will write down now? Sir, sigma 1 is 273. Then they will write down the 45 degrees. If you ask this question, third question alone, if you ask only this question, determine the sigma 1 and its plane location, sigma 2 and plane location, what they will do it now? 90% they will not use this now. They will use this method now. They will use this method. Then what they will write down now? Sir, sigma 1, 273. Here first value is what? I am getting about a first value I am getting 273. Then directly they take the theta 1 is about a 45. Sir, here I am getting the first value is what now? By taking the plus sign, I am getting a sigma 1. By taking the minus sign, first value is the sigma 1. Then they take the 45 degrees. And sigma 2, this is a method most of the low standard textbooks and most of the students also use this method now. And sigma 2, already some of your friends are asking, sir, why you have to do all this thing directly? Can give the answer directly? Why you need all this one now? It's incorrect now. Means as per this one, what you are getting now? Tensile stress maximum at 45 degrees. Compressed stress maximum at 135. But if you use this now, what you are getting now? Tensile stress maximum at what angle now? 135. Compressive stress maximum at about 45 degrees. So this is incorrect now. That's why I mentioned this equation should be only for the principal plane. This is only for principal stress. But if you ask the principal stress and principal plane, that is required now, compulsory now. This is an independent calculation. This is an independent calculation. There is no direct correlation now. This 273.205, whether will exist on 45 degrees or 135, we don't know. And this minus 73.205 will exist on 45 or 135, we don't know. It is an independent calculation. This is an independent calculation. So there is no direct correlation between these values and these values. That's why whenever I ask the principal stress and principal plane location, you have to use this method now. The incorrect approach now. My dear friend, there is no 0, there is no minus 0. What I have to answer, my dear friend, Mr. सुमित कुमार, आप इतना क्लास अटेंड किया था, कितना सब्जेक्ट अटेंड किया था, क्या पूछ रहे हैं आपने, वही क्वेश्चन भेज रहे हैं आपने. That's why I taken this example now. So whenever he asks principal stress and principal plane location, corresponding plane location, you have to go for this method only. Don't use this this equation should be used only for this equation only for principal stresses. Suppose if you are well, Mr. Sumit Kumar, you are asking about the same question 10 times now. If you are calculated value like this, if you ask the round off it to third decimal, in the question is asked about now, sir third decimal बोले तो क्या करना sir बोल के वही question you are repeating now. 98.12367 you are getting your calculated value. But in the question is asking what now? Round off it to third decimal means what you have to do it now? This is what the more than 0.5. Then you have to go for 1 to 4. So this also I have to teach her what now? Your calculated value this now. But in the question is asked what the round off it to up to third decimal means what you have to do it now? This is what a more than 0.5, then automatically this value will be what now? 98.124. What you are asking, Mr. Chinmaya? What you are asking? Whom you are asking that question? Sir, have you attempted GATE exam in after coming to Made Easy? Why you want it now? You don't have any common sense or what? You ask the question which is related now. Why should I appear for GATE exam now? I have already cleared what a GATE in what now? I already completed my MTech and everything now. I completed what I appeared for GATE in 1991. Some friends, they don't have common sense now. Sir, have you attempted GATE exam after coming to Made Easy? Why should I attempt that now? And why you need all this information now? You are mad or what now? Before joining Medis itself, what I worked 20 years in the college now. I completed in my MTech, BTech in 1991 and appeared for GATE exam 1991. I completed my MTech now. Then I worked in the industry, then I joined in the college. For 20 years I worked as a what now? As a professor and assistant professor and MTech coordinator. Then I joined in the Medis in 2007 now. Don't send unnecessarily what now? Focus on your goal. Some mad persons are sitting in the what now? Don't behave like a pagal now. Sir, I attended GATE in what after coming to the Medis. Whether I attended or does not, and what do you need it now? At the age of 60 years also you appear for GATE now. Some students leave their what a goal, their goal. They are going to bother about other person only. Chinmaya Dehuri, try to do the research now. How many faculties has done appeared for GATE? Try to do this research only. Leave your what a goal. First try to focus what you have to do it now. Next, write down maximum shear stress planes. And corresponding stresses. Corresponding stresses. Maximum shear stress plane and corresponding stresses. So already you have studied these planes now. Maximum shear stress planes are the complementary planes on which shear stress is maximum, but normal stresses may or may not be zero. How many ways these planes are located? You have studied that these planes are located by only one method. What that method? Now equating the Taoist equation to zero. Equate is a differentiating Taoist equation with respect to theta and equate to zero. And on this plane, how many stress are there? Now shear stress is going to be maximum. And the normal stress on this plane you are written as sigma and star. Sigma and star is the normal stress on this plane. First location. Location of tau max planes. Location of tau max planes. Differentiating Taoist equation with respect to theta and equate to zero. So for all this calculation, what the input data? All the calculation input data, the state of stress, that is sigma x, sigma y, tau xy is going to be required now. So what this denominator you have studied, this denominator term is representing the principal plane location. What the principal plane location is written tan 2 theta equal to 2 tau xy upon sigma x minus sigma y. Now once again by substituting you are going to get the two values for 2 theta. But always the planes are represented by theta. We are using theta 1 and theta 2 for principal plane locations. Theta 1 and theta 2 are for principal plane locations. Theta 1 is what? Representing location of the major principal plane from x face. Theta 2 is about the location of minor principal plane from x face. Now this theta 3 and theta 4 are representing the location of tau max plane from x face. All the what? Thetas are measuring from x face. If I am getting a theta as positive means that will be measured in the clockwise direction. Theta I am getting negative means it is going to be in the anti-clockwise direction will be there now. And what the angle between these two planes now? Now, this equation compulsory or optional now? This equation is what now? Whatever this equation is a compulsory or optional. This equation compulsory only when principal plane locations are unknown. When principal plane locations are unknown, then the equation is compulsory. But if you already know principal plane location, then this equation is optional. Why now? Because always these planes are at what angle to the principal plane now? 45 and 135 degrees now. Angle between the principal plane and tau max planes is going to be 45 degrees. So the equation is compulsory when principal planes are unknown. When principal plane location unknown. But if you already know principal plane locations, at that time the equation is optional. to locate tau max planes when compulsory to locate tau max planes when principal plane locations are unknown. Now, on this plane, how many stress are going to be there? Now, two stresses. One is what now? Shear stress maximum. Other one is the normal stress. What the sigma and star you have studied now? Normal stress on tau max plane. In plane tau max. Shear stress on tau max planes. These planes are important with respect to which material component? Ductile material component. Principal planes are important with respect to brittle material components. Now to get the sigma and star. Sigma and star, the normal stress on tau max plane. Normal stress on any plane is going to be calculated by sigma and equation. You already got the plane location, theta 3 and theta 4. So how to find out this value? Now by substituting value of theta 3 or theta 4 in sigma and equation. And this is how we are going to get it. Now this is shear stress on tau max plane. So once again this is going to be determined by substituting either theta 3 or theta 4 in Tau's equation. First method is based upon the definition, based upon the concept. Now to get the sigma and star. In sigma and equation, in place of theta, either theta 3 or theta 4, any one value can substitute it now. In sigma and equation, you substitute either theta 3 or theta 4. So what the sigma and equation now? 1 by 2 sigma x plus sigma y 1 by 2 sigma x minus sigma y cos 2 theta 3 and tau x y already know sigma x, sigma y, tau x, but the unknown theta 3, already got it here now. Theta 3 represents the location of tau max plane. So now you can get the sigma and star. You can get the sigma and star. Somebody will ask, no, sir, shall I substitute the theta 3 or theta 4? You can substitute any value, either theta 3 or theta 4. Both will give the same value and same sign. Suppose if I substituted theta 3, I am getting plus 100. Even if I substitute the theta 4, I am going to get the same value. What you have studied now? Complementary normal stress may be equal, may be unequal, may be like or may be unlike. And even in case of day before yesterday, I studied now, uniaxial state of stress. What the sigma and star, you got it now? Sigma by 2. We have done it for uniaxial case now. But the sigma and star, sigma by 2. Even at 45 degrees or 135 degrees, you are going to get the sigma by 2. So normal stress on tau max plane, on both the tau max plane is same. Whether you substitute theta 3 or theta 4, you will get the same value, you will get it now. Same value and same sign. Next, how to get the in-plane tau max? In-plane tau max is what now? Shear stress on tau max plane. Shear stress on tau max plane. Now to get it now, shear stress on any plane is determined by using Tau's equation. And once again in Tau's equation, either you substitute theta 3 or theta 4. What the Tau's equation is written now? Minus 1 by 2. Minus 1 by 2 sigma x minus sigma y. Substitute either theta 3 or theta 4. Sin 2 theta 3. Tau xy cos 2 theta 3. In plane tau max equal to plus or minus. Now if you substitute the theta 3, I am getting plus 100. But if I substitute the theta 4, I am going to get a minus 100. What you have studied now? Always on two mutual perpendicular planes, shear stress are equal unlike. But the angle between theta 3 and theta 4, 90 degrees, they are complementary plane. Always on complementary plane, shear stress are equal unlike. So if I substitute the theta 3, if I am getting a plus 100, theta 4, I am going to get the same value, but minus you are going to, because they are unlike in nature. But what about the normal stress? Whether you substitute theta 3 or theta 4, you are going to get the same value and same sign. So this is the actual method now. But I am going for the now second method. Second method, the second method equation, whatever I am writing the second method equation, they are all obtained from the Mohr circle. So whatever you are studying, these are all analytical method. Analytical method means for everything you have to use the equation. We are going to study the one more method, the graphical method, that is the Mohr circle. That is simply drawing a circle, you will get it now. So now whatever the second method I am writing, the second method equations, they are all obtained from the Mohr circle. When I am going to explain the Mohr circle, I am going to prove this equation. Time being, you can try to remember it. Try to remember the equation, but how we got it when you are going to discuss the Mohr circle. So whatever the method you are studying, this is analytical method. Analytical method means by how to find out the stress on any plane by using the equations. We are going to study the one more method, graphical method, that is the Mohr circle, without using any equations. So these equation, whatever I am writing now, they are all obtained from the Mohr circle. Second method. To determine sigma and star in plane Tomax. In plane Tomax. So all these equation, whatever the second method I am writing, they are all obtained from the Mohr circle, graphical method. Mohr circle. So what the advantage of this method? Directly what, if you know sigma x and sigma y, directly you will get the sigma and star. So the normal stress on tau max plane is equal to, normal stress on tau max plane is equal to half of the sum of the principal stress or half of the normal stress on x and y phase. Sir, how we got it? This I am going to prove it in the what a Mohr circle. Next. In plane Tomax. This is the actual method now. First you have to find out the theta and then you have to substitute it. This is the actual method. In place of this one, directly you can use this is in plane Tomax equal to plus or minus sigma 1 minus sigma 2 by 2. So normal stress on tau max plane is equal to half of the sum of the principal stress. But the shear stress on tau max plane is equal to half of the difference of the principal stress. Normal stress on tau max plane equal to half of the sum of the principal stress. But in plane tau max equal to half of the difference of the principal stress. This only you are calling as the radius of the Mohr circle. Diameter of the circle is going to be given by sigma 1 minus sigma 2. So the difference is going to be given the radius. So it will be equal to radius of Mohr circle. Radius of Mohr circle. Diameter of Mohr circle for stress is equal to sigma 1 minus sigma 2. This is all you are doing the stress analysis. Same thing you are going for the strain analysis. Similarly, when you are going for a strain, epsilon 1 minus epsilon 2. That is representing the diameter of the Mohr circle for strain. Yesterday studied what now? Strain analysis similar to stress analysis. Strain analysis similar to stress analysis. Normal stress should be replaced by corresponding normal strain and shear stress by half of the shear strain. So if you ask what the diameter of the Mohr circle for strain, epsilon 1 minus epsilon 2. So what the expression for this now? Sometime directly objective question will be given now. Sigma x, sigma y, tau x, y is given. Find out the principal stress, Mohr circle diameter. This will be equal to how much is now? You know the just now sigma 1 and sigma 2 equations here written now. Sigma 1 minus sigma 2 equation, it will give the sometime objective question will be given now. Directly sigma x, sigma y, tau x, y is given. Then what the radius of the Mohr circle? If you know the diameter, radius will be half now. So without drawing a Mohr circle also directly can get it now. Sometime objective is a standard gate and ESC question now. Sigma x, sigma y, tau x, y is going to be given. Find out the diameter of the Mohr circle. Radius of the Mohr circle for stress is equal to So what the conclusion of the first method is optional. But when I can use the second method equation now? When I can use this equation? If you know principal stress, if you know the principal stresses and principal plane location, if you know sigma 1 and sigma 2 and plane location, then directly you can get the tau max plane location. If major principal plane is inclined at an angle of 30 degrees, theta 1 is 30, then automatically what the theta 3 angle between principal plane and tau max plane is 45 degrees now. If a theta 1 is 30 degrees, then automatically theta 3 will be 30 plus 45, 75 degrees now. And once theta 3 is 75, what about theta 4? Angle between theta 3 and theta 4 is 90. So theta 4 is going to be 165 degrees now. So if I know the principal plane location, directly what now you can get the tau max plane location. Similarly, if I know the principal stresses, then directly you can get the stress on the tau max planes. Stress on the tau max plane, sigma and star and in plane tau max. Directly you can get it now. Next, absolute tau max. Absolute tau max. This is representing maximum shear stress at a point. This in-plane and absolute are important concept now. So many times the questions will be there in absolute tau max equal to maximum shear stress at a point. Now I'm writing for triaxial equation, absolute tau max. Larger of just now you studied what, now you are getting two values now, plus or minus. Absolute means I'm interested only magnitude, that's why I'm taking the only mod now. But if you go for triaxial case now, how many principal stresses are there now? 3. I'm writing for triaxial case here now. Triaxial equation can be used for the lower order case now. So if I know the triaxial equation for biaxial, which one you have to make it now? Sigma 3 0. Now these are all representing in-plane tau max. Is the maximum shear stress when the point belongs to x and y faces. Is the maximum shear stress when the point belongs to y and z faces, and this is what when the point belongs to x and z. I want to get the maximum shear stress at this corner point. If I want to get this is about the point. At this point I want to get the maximum shear stress. This point belongs to x and y and z. Our equations are valid for biaxial. So first you are going to assume this point belongs to x and y. X and y face what the independent component? No, 3. Sigma x, sigma y, tau xy. Then you are going to get 1 in plane tau max. Similarly, this corner point belongs to y and z. And y and z what the independent component? No, sigma y, sigma z and tau yz. Sigma y, sigma z and tau yz. Then you are going to get 1 more in plane tau max. Similarly, the point belongs to this x and z. X and z. Then your x and z, how many independent components are there now? Sigma x, sigma z, tau xz. Sigma x, sigma z, tau xz. Then you are going to get 1 more in plane tau max. But I'm interested in the maximum shear stress at this point. Whether this point belongs to x and y or y and z or x and z. All. Then I have to take a larger value. So this value is represent the maximum shear stress when the point belongs to x and y. This is what now? Y and z and x and z. Now just now you have written this equation is what assuming the point belongs to x and y. X and y faces. Similarly, when you go for y and z, if you want to use the first method now, if you want to use the first method, what the in-plane tau max equation now? Minus y and z. X and y face what the independent component? 3. Sigma x, sigma y, tau xy. When your point belongs to y and z, what change you have to make it now? Sigma x, sigma y, sigma tau xy should be replaced by sigma y, sigma z and tau yz. So what should I write now? Minus 1 by 2 sigma y minus sigma z sin 2 theta 3 plus tau yz cos 2 theta 3. Cos 2 theta 3. same thing what when a point is belongs to x and z, sigma x minus sigma z, and here what should I write? Tau xz. So like that you are going to get a 3 in plane tau max. Sir, why you are doing like? Because your equations are valid for biaxial case. So 3 in plane tau max are there, but this is for triaxial case. But we are studying for the biaxial case, which is 0 now. Sigma 3 0. For biaxial state of stress, this in plane and absolute is very important concept. Most of students are going to get it out now. For biaxial state of stress or plane stress problems, biaxial state of stress or plane stress problems, sigma 3 0. If you make the sigma 3 0, what the absolute tau max now? Larger of now out of these three now, which is the larger? Everybody is going to tell sigma 1 by 2 is the larger. We cannot directly tell it now. When the sigma 1 by 2 larger, now both are going to be like in nature. If sigma 1 and sigma 2 both are like in nature, it is a sigma 1 by 2. But if sigma 1 sigma 2 are unlike in nature, which is the larger? Now this will be the larger. Suppose sigma 100 sigma 250. Sigma 100 sigma 250. What about this now? 100 minus 50. This will become a 25. It is also 50 by 2, 25. But this 100 by 2, 50. So which is the larger? No, sigma 1 by 2. So when the principal stresses are unlike in nature, so what the absolute tau max? No, sigma 1 by 2. But if they are unlike in nature, one is a positive, one is a negative. Sigma 1 is 100, sigma 2 minus 50. Sigma 100, sigma 2 minus 50. So this will become as what? 150 by 2, 75. This is 50 by 2. 25, and this is what? 25, and this is 50. 75, 25, 50. Which is the larger? No, this is the larger. But most of them are going to mention sigma 1 by 2 the larger now. So absolute tau max is equal to, in case of biaxial, state of stress. Directly what you can write down, absolute tau max is equal to sigma 1 by 2 or sigma 1 minus sigma 2 by 2. Sigma 1 minus sigma 2 by 2. So when this is valid now, uniaxial, what the uniaxial here written now? When bar subjected to pure axial, what the tau max here written now? Axial stress upon 2. So when this is valid now, it is valid under uniaxial as well as biaxial. But when it is valid biaxial, when the principal stresses are like in nature, and this is biaxial when the principal stresses are unlike in nature. Now I want you can also write down for uniaxial. For uniaxial, which one you have to make it 0 now? Sigma 2 0. Sigma 2 and sigma 3 both is 0. Then this will become as sigma 1 by 2, 0, sigma 1 by 2. So which is the larger? Now sigma 1 by 2. for biaxial state of stress. When are like in nature. This is when sigma 1, sigma 2 are unlike in nature. When sigma 1, sigma 2 are unlike in nature. Most of the low standard textbook, they will not mention in plane or absolute. Simply they will write down the tau max equal to sigma 1 minus sigma 2 by 2. Only standard textbooks you are going to get this concept of in plane and absolute now. Suppose in the question is asked only in plane tau max. But if you go for now, these are all once again in plane only. If you go for biaxial, how many in plane tau max are there? No, 3. 1, 2, 3. But if nothing is mentioned, in plane means you have to go for sigma 1 minus sigma 2 by 2. These are all once again what now? In plane tau max. In plane tau max. So if nothing is mentioned, simply ask to calculate the in plane tau max. Default in plane tau max means you should go for even in case of uniaxial, what the tau max you got it now? One is sigma 1 by 2, other one is minus sigma by 2. Two values here, one is a plus, one is a minus. On 45 degrees plane, I am getting a plus 100. 135 degrees plane, you are going to get minus 100, you are going to get it now. So whenever it asks the in plane tau max, then you have to go for, or clearly ask what now? What the maximum shear stress on tau max plane, then you have to go for this now. But whenever is mentioned at a point, then you have to go for this absolute tau max. So absolute tau max equal to either sigma 1 by 2 or sigma 1 minus sigma 2 by 2. So when this absolute tau max and in plane tau max are equal now, when absolute tau max equal to sigma 1 minus sigma 2 by 2, when principal stresses are unlike in nature. So whenever what a biaxial case, when the principal stresses are unlike in nature, both sigma 1, sigma 2 are unlike in nature. In plane and absolute both are going to be same. In plane and absolute both are going to be same. But when both are different now, like in nature, when the principal stresses are like in nature, but the absolute tau max sigma 1 by 2. Unlike in nature is a sigma 1 minus sigma 2 by 2. Some of the old engineering service paper directly they are given the three principles, so sigma 1, sigma 2, sigma 3 is given, and find out the maximum shear stress, absolute tau max. Then you have to go for this three now, larger of you have to consider now. In plane tau max and absolute tau max. absolute tau max are equal in magnitude under following state of stress conditions. One is uniaxial state of stress. Uniaxial state of stress condition. Since both are equal, directly I written sigma 1 by 2. That only I mentioned, Mr. Supreet. If you know already principal plane, directly you can get the tau max plane. But you have to use that equation when without knowing the principal plane, directly want to calculate the tau max planes. Then you have to go for that equation. Otherwise, if you already know principal plane, directly you know the tau max plane, because angle between the principal plane and tau max plane is going to be 45 degrees now. Angle between principal plane and tau max plane is going to be 45 degrees now. Now you can check it now. For uniaxial, what is this value now? Sigma 1 by 2, 0, sigma 1 by 2. What is the absolute tau max? Sigma 1 by 2. Even in plane is also going to be sigma 1 by 2. Even in plane is also sigma 1 by 2. That's why when you are studying the uniaxial state of stress, you are not said simply you are written as what a tau max only you are written now. In plane tau max, whenever is mentioned the in plane, you have to go for plus or minus, because 45 degrees you are getting plus sigma 1 by 2. Another one you are getting minus sigma 1 by 2. So whenever is mentioned in plane, you go for plus or minus. Otherwise, absolute means only you have to go for magnitude. Biaxial state of stress condition. Some case I am going to write down simply tau max. What the meaning of tau max mean what now? When I should write down simply tau max, when in plane and absolute both are same. When in plane and absolute both are same, simply you can call the tau max. But when both are different, then you have to clearly write down what now? In plane and absolute. If both are going to be equal in magnitude, simply can call the tau max. Under uniaxial both are same, that's why we have called the tau max only. But biaxial case only, when they are equal in biaxial case, when the principal stresses are unlike in nature. So overall, when generally you are dealing with a biaxial only, most of your problems are biaxial only. Your syllabus restricted biaxial state of stress only. So under biaxial state of stress, when in plane and absolute both are different now, is a in plane. But absolute is equal to how much? No, sigma 1 by 2 when unlike in nature. When principal stress are like in nature, but the absolute tau max sigma 1 by 2. In plane tau max. So both are going to be different. In plane tau max and absolute tau max are different in magnitude only in which case now? When sigma 1, sigma 2 are like in nature. Sigma 1, sigma 2 like in, only when the principal stress are like in nature. Yesterday studied the pressure vessel example. Hoop and longitudinal stress, both are going to be tensile. In that case, directly principal stress are, one is the hoop stress, other one is the longitudinal stress. In that case, in plane and absolute, both are going to be what now? Same or different or different. So I'm going to explain this here, what this in plane and absolute. Now what this dot now? Point. Now what this three plane now? Three mutual perpendicular plane passing through a point. Now I want to get the maximum shear stress at this point. Now whether this point is belongs, this is a x, this is a y and z. Whether this point is belongs, just now I explained with a duster. Whether this point is belongs to x and y or y and z or x and z all. Because your equations are valid for biaxial. But I want to get a maximum always whenever you are designing, when you are calculating the dimension, design means you have studied now. Whenever you are calculating the dimensions of a component, that is when you are designing, you have to go for an absolute tau max because that will give the maximum shear stress at a point. So I want to get the maximum shear stress at this point. So first you are going to assume this point belongs to x and y. Then one in plane tau max, that is sigma 1 minus sigma 2 by 2. When this point belongs to y and z, one more in plane tau max, that is sigma 2 by 2. When the point belongs to x and z, you are going to get a one more in plane tau max, that is sigma. Here sigma 1 minus sigma 2 by 2. Here what? A sigma 2 by 2. And here sigma 1 by 2. So finally what the maximum value means, you have to consider what now? Larger of all these values now. This is sigma x. In our case, we are neglecting the biaxial means what we are considering the stress only on x and y. Z phase you are neglecting. Biaxial state of stress means what you are studying now. We are considering only x and y. Why Z phase is neglected. So when the point belongs to x and y, what are the independent components? Three. What are they now? Sigma x, sigma y, tau xy. Then you know the equation now. What the? Just now I written now for x and y. What the tau equation now? When x and y now? Minus 1 by 2 sigma x minus sigma y sine 2 theta plus tau xy cos 2 theta. Then you have differentiated that equation and equal to 0. You got the value of theta and that value you substitute in the tau equation. Then you got the in plane tau max. So how we got that in plane tau max now? When the point belongs to x and y. Minus 1 by 2 sigma x minus sigma y sine 2 theta 3 plus tau xy cos 2 theta 3. Next you have to assume the point belongs to y and z. Everybody goes, sir, z phase there is no stress. But when point belongs to y and z, Independent component 3. What are they? No, sigma y, sigma z and tau yz. But which one is 0? No, sigma z is 0 and tau yz is. But which one is there? No, sigma y. So when the point is belongs to y and z, it is become as a uniaxial. When the point is belongs to y and z, there is no stress on z face. Only on y face is the uniaxial. That's why it is written as what now? Sigma 2 by 2. Uniaxial case, what here written now? Tau max is equal to u. When a bar subjected to pure axial load, what the tau max here written? Sigma 1 by 2. So similarly, what when the point is belongs to these two now, it is becoming the uniaxial. There is no stress on the z face. Only uniaxial now. That is the y face. So what is the actual method now? What the how to find out this now? Minus 1 by 2 sigma y minus sigma z. Just now written now. Sigma x, sigma y, tau xy should be replaced by sigma y, sigma z and tau yz. But which one is 0 now? Sigma z is 0, tau yz is 0. Only sigma y will be there. So you are going to get a 1 in plane tau max. Everybody is going to tell, sir, z face there is no stress. Why you are considering? Z face there is no stress. But when the point is belongs to the sigma y is going to be there. Because that sigma y you are going to get a 1 more in plane tau max. Next, this point is belongs to x and z. X and z. When the point is belongs to x and z, how many independent component now? Sigma x, sigma z and tau xz. But once again, sigma z is 0, tau zx 0. Then automatically tau xz is 0. But only which one is left out now? Sigma x is going to be there. So because this one more tau max you are going to get it. So 3 tau max you are getting. When the point is belongs to x and y, 1 in plane tau max. When the point is belongs to y and z, 1 in plane tau max. X and z 1 now. And by using that second method, what you can write when the point is belongs to these two now, by using the second method, what the in plane tau max now, by using the short second method now, sigma 1 minus sigma 2 by 2. When the point is belongs to these two now, what the in plane tau max now, sigma 2 minus sigma 3 by 2. But biaxial case sigma 3 0. Then it is going to be sigma 2 by 2. Next, the point is belongs to x and z. So what the in plane tau max now, sigma 1 minus sigma 3 by 2. But once again sigma 3 0. Then you are going to get the sigma 1 by 2. That only I have written here now. So first you are going to assume the point is belongs to x and y. Directly I written the second method I written now. If you go for a first method, what I had to do it now, just now I written now. In plane tau max equal to, in Tau's equation you have to substitute the either theta 3 or theta 4. Then what the equation? Minus 1 by 2 sigma x minus sigma y sine 2 theta 3 plus tau xy cos 2 theta. That is the first method now. Otherwise you can use the second method. This is what by using the more circle now. Next, we are going to assume this point belongs to y and z. When the point belongs to y and z, how many independent? This is what a sigma z. It is 0. This is what a tau zy, and this is tau yz 0. How many are left out? Independent component biaxial. How many are there? 3. 2 normal and shear. 1 shear. But here which one are 0? Sigma z 0, tau yz 0. Only which one will be there? Sigma y. So when the point belongs to y and z, sigma 1 minus sigma 3 by 2, sigma 1 minus sigma 3 by 2. But it's becoming a uniaxial. There is no stress on z face. There is no stress on z face. Therefore, for biaxial case, which one is 0? No, sigma 3 0. Then only you are getting sigma 1 by 2. Or sorry, sigma 2 minus, this you can make it as sigma 2 minus sigma 3. For biaxial case, what? There is no stress on this now. Then this will be equal to plus or minus, because sigma 3 is 0. Same thing, you can assume the point it belongs to x and z, but the independent component is sigma x, sigma z and tau xz. But once again sigma z 0, tau xz 0. Only which one will be there? No, sigma x. Once again it will become as a uniaxial. Then what should I write now? Plus or minus sigma 1 minus sigma 3 by 2. But biaxial case sigma 3 0. Then you are getting sigma 1 by 2. But whenever I'm designing, I need the maximum shear stress at this point. This much of shear stress when you are getting when the point it belongs to x and y. This much of maximum shear stress when the point it belongs to y and z. When the point it belongs to x and z, this much of shear stress is there. So finally, if I want to get a maximum shear stress at point, then I have to take a larger value. That only I written here now. So whenever it asks at a point, you have to go for absolute tau max. But for biaxial directly can give it now. What now? Like in nature sigma 1 by 2. Unlike in nature sigma 1 minus sigma 2 by 2. Unlike in nature sigma 1 minus sigma 2 by 2. Then question will be what now? Already some friends are already asking now. Sir, how to decide in the question? Some question directly they are mentioning in plane tau max. Some question they are mentioning absolute tau max. But some question they are mentioning simply only maximum shear stress. Then how to decide it, sir? In the recent papers, clearly they are mentioning in plane tau max or absolute tau max or at a point. Whenever is mentioned at a point, then you have to go for absolute tau max. Or simply maximum shear stress on a plane means in plane tau max. But some question that is also not mentioned now. They will give sigma 1, sigma 2, find out the tau max. So when you have to go for absolute tau max, whenever is what mentioned at a point, or whenever you are doing design calculations, whenever you are calculating the dimensions, and when you are going for theories of failure, one theory is called a maximum shear stress theory. And whenever it is mentioned in a member, determine maximum shear stress in a pressure vessel due to fluid pressure in a member means once again you have to go for absolute tau max. But if nothing is mentioned in the question, simply sigma 1 and sigma 2 are given, determine maximum shear stress. If nothing is mentioned, you go for in plane tau max. Nothing is mentioned. But whenever you are designing, whenever it asks at a point in a member, then you have to go for absolute tau max. absolute Tomax should be considered. In the following situations or conditions. Some common doubts are going to be there for the students now. Common doubts. Still, those who have completed coaching 2 years back, sir, what the polar axis, what the longitude axis? What the polar axis, what the longitude axis? Sir, what the Tomax plane, what the planes of pure shear? And sir, what is the in-plane Tomax? When should I take the in-plane and absolute? They will not refer the class notes. They will see the solutions only. And they are going to depend upon the low standard solutions. Low standard solutions. X person will give the solution for total mechanical engineering now. And we are going to depend upon that solutions. Don't depend upon the low standard solutions. Directly try to refer your class notes. All the made the teacher class notes is going to be sufficient. If any query, try to refer your class notes, you will get it now. Don't depend upon the solutions given by some X person. We don't know its qualification. We don't know what is his qualification. Whether the production or thermal or design or mathematics, we don't know. And we are going to depend upon that solution. Then unnecessarily you are going to get a confusion. Once you have joined the MADEZ, all the MADEZ teacher class notes is sufficient. Believe yourself, believe the MADEZ and believe the teachers now. But don't believe the what now? Unnecessary low standard solution. Nowadays what now? So many solutions are available, so many test series are going to be there, so many low standard are going to be there. They will create they don't know what now. Either production or thermal, you will going to give a strength of material question, machine design question now. And they will also give a mathematics question, reasoning and aptitude. And this question everybody is what now, when during the COVID period, MADEZ created a group for the mechanical engineers now. MADEZ mechanical engineer, there are some other, it was common for non-MADEZ students also. So many questions. Somebody is going to post a question in that group. And somebody will give the in-plane Tomax, somebody will give absolute Tomax. And they are going to give their own conclusions now. And some students will ask, sir, can you give what the answer now? I'm going to clearly mention them. Try to refer your class notes. If any query is there, try to refer your class notes. The class notes is going to give each and every information. They will collect the material, but they will not refer the notes now. So to avoid this type of ambiguity in the class, I'm going to give this type of points now. Absolute Tomax should be considered in the following cases or following condition. In the determination of maximum shear stress at a point. Whenever it is mentioned at a point, you have to go for absolute. In the determination of maximum shear stress in a member, determine the maximum shear stress in a shaft, maximum shear stress in a bar, maximum shear stress in a member. In the design calculations. That is what now, whenever you are calculating the dimensions in the design calculations, factor of safety calculations. Next, in the maximum shear stress theory, in the entire subject, this is what a very important chapter for mechanical engineers now. Almost this chapter I am going to take the around 20 hours. Another important topic is the SFD BMD. That I will take almost 25 hours now. These are the two important, but out of these two now, this chapter is very important for mechanical. If you are thorough with this one, then you are going to be thorough with the theories of failure. And if you are thorough with the theories of failure, then you are going to be thorough with the machine design now. So then when should I go for an in-plane? Either they will clearly mention in-plane, otherwise simply they will ask what now? Find out the maximum shear stress. They will not mention at a point or in a member or design calculation. Simply sigma 1 and sigma 2 is given. Simply sigma 1 and sigma 2 are given. Determine the maximum shear stress. In a biaxial state of stress, principal stress are 130. Determine maximum shear stress. If nothing is mentioned, whether it mentioned at a point or member or design calculations, then you have to go for in-plane. If nothing is mentioned, simply ask calculate the maximum shear stress. Then you have to go for in-plane Tomax. If nothing is mentioned, you have to go for the in-plane. For a point under biaxial state of stress, principal stresses are for a point under biaxial state of stress, principal stress are 150 megapascals. 150 megapascals. Now can you give what is the answer for this now? If the options are given like this. For a point under biaxial state of stress, principal stress are 150. Determine maximum shear stress. 25, 50, 75, 100. Now what is the answer for this question now? Rupesh Kumar, answer is B, 50. Any other answers? I'm waiting for the options and answers now. Mr. Rupesh is given option is B. Somnath Mandal 25, Chinmay. Pritham Jyoti, Satyendra Kumar, C. How you are getting C, my dear friend Satyendra Kumar? You are the only one person who got the answer is 75. B. Majority is what now? Bipan Kumar, 25. Everybody is what now? Mr. Somnath Mandal, Bipan Kumar, Abhyuday Sharma, 25 is given. Remaining all are given 50. Satya 50. Raghav 25, Himanshu 25, SD Shastri 50, Biswa 25. Mayank Sharma 20. Answer now. Answer is 25. Teak says Suno. Just now what I mentioned now. Absolute Tomax. This is what now? In plane Tomax, this is the absolute Tomax. Even I written also still there what now? Everybody is what the 20 sir, like in nature sir, they are like in nature sir, sigma 1 by 2. But when you have to go for absolute Tomax now, this is in plane Tomax, this is absolute Tomax. This will be equal to how much is now? This is absolute Tomax. Simply what now? Sir, you mentioned when sigma 1, sigma 2 like in nature, sigma 1 by 2. But that is absolute Tomax. But in the question, when you have to consider absolute Tomax now, absolute Tomax should be considered at a point or in a member design calculation. Are you calculating anything now? Simply ask the maximum shear stress only. If nothing is mentioned, you have to go for in plane only. So you have to go for the answer is what now? When you have to go for option B is correct. Now if you ask the same question now, determine maximum shear stress at that point. Then you have to go for option B. So answer is what now? A. Somebody is getting 75 also. How he is getting 75? I don't know now. Initially they are given, most of they are given the answer is what? A B. Now at the end most of they are given the answer is what now? A. If you ask the same question now, determine or if you ask the same question now, determine the factor of safety by using maximum shear stress theory, then you have to go for absolute Tomax. You have to go for in plane, but for this question what the answer now? B the answer. Please try to refer the vote now, each and everything now. So for second question answer is going to be B. First question answer is A. सुखविंदर सिंह बी ऑप्शन दिया था आपने. किधर दिया जी? Always the principal stress are calculated at a point only, no? Always the principal stress are calculated at a point only. Where is mentioned? At a point is mentioned, no? All the analysis at a point only. Somebody what, sir, you mentioned at a point. This is what now? Always the principal stress are calculated at a point only. Everywhere the stress analysis is done at a point only. Sir, you mentioned at a point and not mentioned what? This is what now? Principal stress are always calculated at a point only. Principal stress are at a point. But in the question what is asked now? Is not mentioned what now? Maximum shear stress at that point. But simply ask maximum shear stress. If there is no meaning, if I not mentioned, there is no meaning for this question now. All the stress analysis is defined at a point only. We are whatever you are doing at a point only. Now I am modifying this question now. I am modifying this question. Now if the question is given like this, 100 and minus 50, 100 and minus 50, 100 and minus 50. Now in this case, shall I take in plane or absolute? Anyone you can take because both are going to be equal in magnitude. What the in plane? Sigma 1 minus sigma 2 by 2. Absolute is also sigma 1 minus sigma 2 by 2. That's why what your decision is required only when student has to take a decision only what now? When they are like in nature. Only when they are like in nature, they are different in magnitude. In plane is different, absolute is different. But when they are unlike in nature, both are same. So for this question, what the answer now? Now this is representing what now? So this itself in plane and this itself absolute. For both the question answer will be C. Clearly written the conclusion. In plane tau max and absolute tau max are equal in magnitude under uniaxial as well as what now? Biaxial when the principal stress are unlike in nature. So for this question, for both the question answer is C. So whenever they are unlike in nature, you can take any one. You need not bother now. आप सोचने की जरूरत भी नहीं है, कोई भी ले सकते हैं अपने. When the principal stresses are unlike in nature, आप कोई भी ले सकते हैं, सोचने की जरूरत नहीं है. Either आप in plane tau max ले को, absolute tau max ले हो, you will get the same answer. In plane और absolute tau max are अलग अलग है, दोनों अलग वैल्यू देता है. कब है? When principal stress are same nature हुए तो दोनों अलग वैल्यू देता है. If nothing is mentioned, you have to go for in plane. If it is mentioned at a point or in a member or designing or theories of failure, you go for absolute tau max. I clearly mentioned, I given this one, I am going to do these questions in the class now. But still, they are going to get a doubt. Some students, what I am talking about, I'm not, any of my statement is not with respect to any of you personally. This is based upon my last 25 years of experience. I have even seen so many students now. If any of my statement is related to, please don't take it personally. If it is by chance related, try to change yourself. Don't take it personally. Remember always the teacher, the best well-wisher, all of you. Go through the class notes. Because they will not, some students, they will not believe themselves also. They will believe some unknown person. In front of you, no, the teacher, maybe the teachers are explaining with so much of time, but still they will not believe. They believe some X solutions now. Now you have completed what now? So once how to? So whenever it asks what now? Maximum shear stress planes and stress on the maximum shear stress plane. Better to calculate the principal stress. If you know the principal stresses, directly in plane tau max is what? Plus or minus sigma 1 minus sigma 2 by 2. Absolute tau max, when the like in nature is a sigma 1 by 2, unlike in nature sigma 1 minus sigma 2 by 2. And just now I explained when you have to consider sigma 1, when you have to consider in plane and when you have to consider absolute tau max. And what the normal stress on tau max plane? Normal stress on tau max plane equal to half of the sum of the principal stress. Half of the sum of the principal stress, or half of the sum of sigma x and sigma y. I have given the first method and the second method. Second method is what now? Second method is valid when the principal stress are known. All the second method, whatever I written, they are all in terms of the principal stress. But that equations are obtained with the Morse circle. When I am going to discuss the Morse circle, it is going to be clear. Now I am completing the presently analytical method. I am completing analytical method. Analytical method means by using the equations. Now left out with what? Now you have completed how to find out the stress on the principal planes and their location you have completed, and tau max plane and the stress on the tau max plane. Then left out with the planes of pure shear. Planes of pure shear or planes of zero normal stress. Planes of pure shear stress. Generally, these planes are not discussed in most of the textbooks. These planes are not discussed in most of the textbooks. Why? Because there is no practical significance. What is the significance of the principal plane? On that plane, tensile and compressive stress or normal stress is going to be maximum now. Principal planes are important with respect to in identifying the fracture plane for brittle material. And tau max plane shear stress is maximum. They are important with respect to ductile material. But on planes of pure shear stress, neither normal stress maximum nor shear stress maximum. That's why there is no practical significance. Tau max planes are important with respect to design of the ductile material components, and principal planes are important with respect to design of brittle material component, with respect to brittle material components. And you give any value of sigma x, sigma y, tau xy. Maybe uniaxial or biaxial or triaxial. Always principal plane will get it. Always you will get a principal plane. Always you will get a tau max planes, you will get it. But planes of pure shear will get it or will not get it. We don't know. Planes of pure shear will exist or will not. Directly we cannot tell it now. Planes of pure shear will exist only when you have studied now. When sigma 1, sigma 2 are unlike in nature. Sigma 1 is what? 100, sigma 250, what you have studied now? Sigma 100, sigma 250. Means normal, all the planes is going to be between 100 and 50. Then the planes of zero normal stress will not get it now. So whenever you want to get a plane of pure shear stress, what is the other name for planes of pure shear stress now? Planes of zero normal stress. So if the normal stress should become zero, means what now? Principal stress should be unlike in nature. So these planes may or may not exist. Suppose in the question sigma x, sigma y, tau x values are given. If a question is given, an MSQ question, for a point under biaxial state of stress, for a point under biaxial state of stress, which of the following statement is or correct now? Principal plane always will exist. Tau max planes will exist. Planes of pure shear will exist. Planes of pure shear may or may not exist. Then in that case, what the answer? Which statements are correct now? First statement is correct, second statement is correct, and fourth one is correct. But planes of pure shear may or may not what? May or may not exist. But we cannot tell what exists now. Well, without knowing the numerical, we cannot tell it now. In the question, what a biaxial state of stress means we don't know sigma x, sigma y, tau x value now. But whatever may be the value of sigma x, sigma y, tau x, what happens now? Principal planes are always exist. Tau max planes will exist, but planes of pure shear may or may not exist. When they will exist now? When they are unlike in nature. When the principal stresses are unlike in nature. But when the principal stresses are like in nature, they will not exist. Morning you also studied, I have taken a question now. Sigma morning first question itself now. Sigma 100, sigma 2 some 25 like that now. So normal stress and remaining all the plane will be between these two now. So all are going to be tensile. There is no compressive stress. There is no planes of pure shear stress. What is the name for planes of pure shear stress? No, planes of zero normal stress. Already I have given the definitions now. Planes of pure shear stress are planes of zero normal stress. And clearly also take an example also. In a class of 100 students, the highest mark is 90, lowest is what, a 10. Means remaining all the students are going to get a positive marks, nobody is going to get a 0 or nobody is going to get a negative. Suppose highest is 90, lowest is minus 10, means what, somebody is going to get a 0 now. So planes of zero normal stress will exist only when the principal stress are unlike in nature. Already the definitions are given. Generally these planes are not discussed because there is no practical significance. But whichever is not important for university examination, whichever is not important for university, that is important for the GATE examination. University examination, we don't need the concept. Without knowing the concept also you can get it. I'm not telling what some students they will not attend a single day. They will produce a medical certificate, they will get the eligibility, he will get the 70 or 80 marks. He don't know what the stress, he don't know anything, he will do about now. Just before the exam, one day before, he will collect the previous papers and he will identify the what, he will do a research on the previous papers. And the same question repeated now. He is going to buy hat and he is going to reproduce in the exam now. He will not attend a single day in a college, but still is going to get the 70 to 80 to 90 also he is able to get it now. But here concepts are important. Whichever is unimportant, that is going to be important here now. So how to get this plane now? Once again I am going for the first method. And what you have said, these plane will become as the tau max plane when now? These planes will become as the tau max plane only when sigma x plus sigma y 0. Tau max plane and plane of zero normal stress. Tau max plane or plane of zero normal stress or planes of pure shear will coincide only when sigma x plus sigma y 0. That is when sigma 1 and sigma 2 are unlike in nature. So these planes will become as the tau max plane only when sigma x plus sigma y 0. That is when sigma 1 and sigma 2 are equal unlike. When sigma 1 and sigma 2 are equal unlike. Now once again I am going for the first method. How to get the location now? Equate the sigma and equation to 0. First method is based upon the definitions only. So once again whatever I am giving the first method. First methods are based upon the definitions. Most of students are going to get a confusion. Sir, this plane will exist when unlike in nature or equal unlike. These planes will exist when the principal stress are unlike in nature or equal unlike. Unlike in nature, that's all. When equal unlike, what happens now? When equal unlike, this plane will become as a what now? Tau max plane. Clearly I mentioned definitions are given, but till yesterday what now? Almost 3/4 students of the what now? Offline batch now. Sir, planes of pure shear will exist when they are unlike in nature or when they are equal unlike. Clearly what I mentioned, unlike in nature, I not mentioned equal unlike. When they are equal unlike, what happens now? When they are equal unlike, sigma and star is 0. Just now you written what now? Sigma and star equal to sigma 1 plus sigma 2 by 2. When sigma 1 and sigma 2 are equal unlike, what happens now? Sigma and star 0. Mean tau max plane will become as what? The planes of pure shear now. Clearly I have given the each and everything definitions I have given. Please go through that definitions and the conditions now. So from this one, if you can equate it to 0. Here because this constant will not get the tan 2 theta or cos 2 theta will not get it. You have to solve it now. So here you will get the and what the another difference is that the principal planes are always complementary. Tau max planes are always complementary, but these planes are not complementary. These planes are complementary only when sigma x plus sigma y 0. So angle between these two is not 90 degrees now. These planes are not complementary planes now. These planes are not complementary planes. These planes are complementary only when sigma x plus sigma y 0. When sigma x plus sigma y 0. These planes will coincide with the tau max plane. Tau max planes are already complementary plane. So if I know the theta phi, we cannot get directly theta 6. Both the values you have to calculate. But in principal plane and tau max plane, what now? If I know one principal plane, directly can locate the other principal plane. Similarly, if I know the tau max plane, you can get the other value because they are complementary. But these planes are not complementary. Both the values you have to determine it now. If I am getting one value 30, other value will not be 120 degrees now. Now already I used the theta 1 and theta 2 are what? Representing the, is not a standard notation. Theta 1 and theta 2 is representing the location of principal plane from x face. Theta 3 and theta 4 are representing tau max plane location from x face. Now theta 5 and theta 6 are location of the planes of pure shear stress from once again x face. Theta 6 is not equal to theta 5 plus 90. This is valid when now? Sometimes here MSQ questions are possible. Which of the following statements are correct with respect to planes of pure shear? These planes are complementary planes, non-complementary planes. They are non-complementary planes. Or if it is given, MCQ question is given. If the MCQ question is given, which of the following statements are correct now with respect to planes of pure shear? They are complementary planes, non-complementary plane. maybe complementary planes or non-complementary plane. Then you have to go for option C. You have to consider now, because they are complementary when now, when sigma x plus sigma y 0. They are non-complementary when now, when sigma x plus sigma y is non-zero. That is, when sigma 1 is not equal to minus sigma 1 is equal to minus of sigma 2. Now you got the plane location. Then on this plane you are going to get a normal or shear stress? Only shear stress. Now tau s star. This notation, whatever, is not a standard notation. It is about my notation I am following. Shear stress on shear stress on planes of pure shear. Now this value equal to tau max or less than tau max or more than tau max? It is less than tau max when in this case, but when it is equal to tau max, when it is equal to tau max, when sigma x plus sigma y 0, this value will be less than tau max. Instead of remembering all, better to remember only what now? The planes of pure shear and tau max plane will coincide when sigma x plus sigma y 0. Planes of pure shear and tau max plane will coincide when sigma x plus sigma y 0. That's all. Now to get the tau s star once again now. How to get the tau s star now? Tau s star, how to get it now? Shear stress on any plane you are going to get by substituting the corresponding value of theta and tau s equation. Now we already got the plane location. So this either theta 5 or theta 6 you have to substitute in the tau s equation. You are correct. Most of their vote, especially during this COVID period, still previously also vote now. In most of the college, they never learned the what of basics now. Even if some of the teachers try to teach the concept now, students will not bother now. Some few teachers are going to be there. They are going to teach it now. Some colleges, some excellent teachers are there. But even though they tries to teach the concept now, students will not bother. Why? They will follow their seniors now. The seniors will tell this is not required. And we are going to take a suggestion from the not right people now. Always take the right suggestion from the right person now. And they are going to tell, we don't need all this thing, university exam, this is required. This is important for university examination, this is, remember it. Try to refer this RS Kurmi. If you can refer this RS Kurmi, you need not attend the class also, directly you'll get the 80 or 90 marks, you are going to get it now. And we are going to follow those persons now. So always take a suggestions or what advice from a right person, whether it's desirable to give your suggestions or not. In the society there, everybody is going to ready to give the suggestions now. Don't take the suggestion for everybody now. Every person now. Take a suggestion from a person who is what now? Desirable to give your suggestions or not, you decide it now. Now to get this tau as a star, in the tau's equation, substitute either theta phi or theta 6. Either you can substitute theta phi or theta 6, any one. Now the same notation I am going to use it when you are going for the Mohr circle also. But now you can see now whether you substitute theta phi or theta 6, you will get the same value but unlike in nature. Based upon this only, what everybody is going to make their own conclusion. Sir, they are equal unlike means they are complementary. Whether you substitute theta phi or theta 6, I am going to get the same value but unlike. Suppose I am substituted theta phi plus 100, theta 6 I am going to get a minus 100, I am going to get it now. Then everybody is going to make their own conclusion. Sir, they are equal unlike, therefore they are complementary planes. Whenever shear stress are equal, they are not complementary plane. Whenever shear stress are equal unlike, the planes need not be a complementary plane. Always on two complementary planes, shear stress are equal unlike. Vice versa is not correct now. When shear stress are equal unlike, they are complementary plane. Vice versa is not valid now. Always on two complementary planes, always on two complementary planes, two mutual perpendicular planes, shear stress are equal unlike. But vice versa is not valid now. What the vice versa now? When shear stress are equal unlike, they are complementary plane. Reverse is not valid now. So once I am repeating now, always on two mutual perpendicular planes, shear stress are equal unlike in nature. But when shear stress are equal unlike in nature, don't call what now? They need not be a complementary planes. When shear stress are equal unlike in nature, planes are complementary planes. That statement is not correct now. Means there may be a planes which are not at 90 degrees. On some of the non-complementary planes, still shear stress values are going to be equal unlike. Now this is what now? On two complementary planes, on complementary planes are two mutual perpendicular planes. Shear stresses are, that already approved it now. Shear stresses are equal and unlike in nature. When shear stresses are unlike in nature, then planes need not be complementary planes. When shear stresses are equal unlike in nature, then planes need not be complementary planes. May be complementary planes or may not be. But the example for this, now, your planes are pure shear, they are not complementary planes. Now I am going for the second method. This is once again from the Mohr circle now. Second method. This equation very useful now. Once again, this is going to be obtained from the Mohr circle. All the second method, whatever I am writing now, previous one and this one, they are all from the Mohr circle only. When you are going to study the Mohr circle, I am going to prove it now. So this is very useful in objective examination now. But if you use the first method, what I have to do it now? First you have to find out the either theta 5 or theta 6. Then you have to substitute it now. But here directly you can get it now. But the equation when they are valid now, if you know the principal stress. Therefore, all the question what better to calculate the principal stress. If you calculate the principal stress, then directly you can determine the stress on the remaining planes. If you know the stress on the principal plane, then directly you can get the stress on the Tomax planes and stress on the planes of pure shear. What the stress on the Tomax plane? Sigma n star, sigma 1 plus sigma 2 by 2. And what the stress on the Tomax planes? That is what in plane Tomax, sigma 1 minus sigma 2 by 2. Absolute Tomax, like in nature sigma 1 by 2. Unlike in nature sigma 1 minus sigma 2 by 2. And tau s star square root of minus sigma 1 sigma. Why this minus sign is there? Because they are unlike. They are possible only one unlike. Sigma 1 is 100, sigma 2 is minus 50. If there is no negative sign, you are going to get an imaginary value now. Now because this minus sign, you are going to get the what value you are good. That's why this minus sign is getting, because sigma 1, sigma 2 are unlike in nature. Next, tan beta. Tan beta is equal to square root of minus sigma 1 by sigma 2. Now what is the beta? What is the beta? So far you have used the theta. Theta is measured from the x phase, but beta is not measured from the x phase. Where beta is the angle between sigma 1 plane and planes of pure shear stress. So then how to get the theta 5, theta 6? From this one I am going to get a beta. Then you already know theta 1. Theta 1. Always the theta is measured from where? Now, x phase now. So if you want to get the location of planes of pure shear, first you have to find out the beta. And you already know theta 1. So if I know the theta 1, then theta 5, theta 6 equal to what now? Theta 1 plus or minus beta. Only I am going to show that beta here now. Always this is a reference now, x face and y face. This is what the major principal plane. This will be inclined at what angle now? Theta 1. On the major principal plane, which one will be there now? Sigma 1. On this plane, shear stress is going to be 0. And what about this red color plane? On this blue color plane, shear stress 0, normal stress maximum. And what about this red color plane? Normal stress 0, shear stress will be there now. On this plane, normal stress 0. This shear stress is what? A tau SS star. Once again, on this plane, normal stress 0. So what these red color planes are? Planes of pure shear stress or planes of zero normal stress, and this is a major principal plane. Now this angle is beta. Beta is the what here at now? Angle between sigma 1 plane and planes of pure shear stress. What this blue color line? Sigma 1 plane. This is the one of pure shear 1 plane now. Now, how to get this now? This is going to be this is theta phi. So, how to get the theta phi? Theta 1 plus beta. Theta 1 plus beta. And what about this value now? Theta 6. Now to get the theta 6, now theta 1 minus beta. So this plane is a which plane now? This blue color plane is what now? Major principal plane. Already I studied some questions, you already done it, how to find out this theta 1 now. And what about this plane now? Plane of pure shear stress. Plane of pure shear stress. And what about this another plane of pure shear stress? This is a reference. Now where you are going to get a sigma 2 plane? 90 degrees to this now. This is a sigma 1 plane. Where you are going to get the sigma 2 plane now? 90 degrees. What the angle between these two now? 90. And this angle is what? A theta 2. This angle is theta 2. That's why what here always angle, what the blue color lines? Blue color lines are the principal plane on which, on blue color line on which shear stress 0. And the red color line which is 0, no, normal stress 0. So the red color lines are the planes of pure shear stress or planes of 0 normal stress. And the blue color lines are the planes of 0 shear stress or principal planes. On this plane you are going to get the so this is another principal plane. Now where you are going to get a tau max plane now? Where you are going to get a tau max plane in between these two now? Suppose this is 30 degrees, this is 30 degrees, and what about this now? 30 plus 90, 120. And where you are going to get a tau max plane? Angle between principal plane and tau max plane is 45. So somewhere you are going to get it now. It's already principal plane. Somewhere you are going to get a tau max plane. Angle between principal plane and tau max plane is 45. So if I know one principal plane, directly can get the another principal plane. But these planes are not complementary. These red color planes are not complementary. Blue color planes are complementary. Blue color planes are complementary. Principal planes are complementary. But the planes of pure shear are not complementary. But they are complementary only when sigma x plus sigma y 0. Only when sigma x plus sigma y 0. So what the theta 1 represent location of major principal plane from x face. What the theta 2 location of minor principal plane from x face. What the theta 6 location of plane of pure shear stress from x face. Theta 5 location of plane of pure shear from x face. Similarly theta 3 and theta 4 are what a location of tau max plane from x face. And where you are going to get a tau max plane? In between these two now. Exactly between these two. Exactly between these two blue color lines, exactly in between you are going to get a tau max plane. And another tau max plane will be 90 degrees. Principal planes are complementary, tau max planes are complementary. But the planes of pure shear not complementary, but they are complementary only when sigma x plus sigma y 0. So this completes the total analytical portion is completed. So now you can complete these questions. Chapter number 7. I'm writing the questions here. Question number 9. Seventeen, 24, 23 also, 23, 32, 'These questions you can complete it now. Based upon today's lecture, these questions are going to be there. 9, 17, 24, 23, 32. So tomorrow I am going to discuss some more questions. Then we'll continue tomorrow now. So today's lecture is completed. If you have any queries, you can first try to refer the day before yesterday. All the definitions are given now. And today I have done some questions. So complete that questions. Apart from this one, I have given the 5 questions. These 5 questions will not take hardly 10-15 minutes, hardly 15 minutes now. Maximum 15 minutes time will take it now. So today's lecture is completed, and if you have any queries, you can send your queries. Otherwise, we'll log off the system now.